In 2019, Google made headlines with the announcement that its Sycamore quantum processor had completed a calculation in 200 seconds that would have taken a supercomputer 10,000 years to accomplish. This breakthrough, detailed in the journal Nature, was hailed as a landmark moment in the field of quantum computing, a field with the potential to revolutionize various sectors, including chemistry and finance. However, the concept of quantum supremacy, as exciting as it may sound, has turned out to be more complex and contentious than initially portrayed. The term, quantum supremacy, first introduced by theoretical physicist John Preskill, refers to the point where a quantum computer can perform a task that is impossible, or at least highly impractical, for a classical computer. Yet, in the years since Google's claim, the idea of quantum supremacy has sparked significant debate among experts. Some argue that advances in classical computing algorithms have cast doubt on the performance claimed by Google's quantum machine. The notion of quantum supremacy, while intriguing, remains elusive and is a subject of ongoing discussion among scientists, many of whom question its importance and even its feasibility. Aventine, a non-profit research institute dedicated to exploring how rapid technological advancements impact science and society, sought the insights of 5 prominent quantum researchers. They asked these experts to weigh in on what quantum supremacy truly means and whether it holds any real significance. Scott Aaronson, Quantum Supremacy as an Evolving Goal. Scott Aaronson, chair of computer science at the University of Texas at Austin, sees quantum supremacy as a milestone that can be achieved, lost, and potentially regained. He explained to Aventine that the ultimate goal is to identify tasks where quantum computers can undoubtedly outperform classical ones, even if these tasks aren't immediately practical. Those of us in the field have known from the start that a quantum computer's value lies in its ability to outperform a classical computer, Aaronson said. The exciting part is that there are a few very specific problems where we're confident a quantum computer will eventually have the upper hand. However, Aaronson acknowledges that quantum supremacy is a moving target, as classical algorithms continue to improve. Quantum supremacy can be achieved and then lost later, he remarked. But we all expect that eventually, we'll reach a point where quantum computers routinely perform tasks that classical computers can't match within thousands or even millions of years, at which point, there'll be no more debate. Sergei Frolov, Quantum Supremacy as a Marketing Strategy. Sergei Frolov, a physics professor at the University of Pittsburgh, views quantum supremacy as both a scientific benchmark and a marketing tool. He suggests that the term was crafted to captivate the public's imagination and justify ongoing investments in quantum research, even if the reality is more modest. Our communication with the public often involves presenting sales pitches, Frolov told Aventine. One such pitch, perhaps unfortunately named, is quantum supremacy. The idea is far less grandiose than the term suggests. Can a machine we've built do something, anything, even if it's absolutely useless, better than classical computers? Frolov believes that even a limited demonstration of quantum supremacy could give researchers more time to refine quantum technologies. If we can show that quantum computers might be useful in the future, it would buy us time to improve them, he said. Joseph Emerson, Quantum Supremacy as an Engineering Achievement. Joseph Emerson, an associate professor at the University of Waterloo's Institute of Quantum Computing, regards quantum supremacy as an important, albeit narrowly defined, milestone. While acknowledging the term's marketing aspects, he also sees it as a significant engineering accomplishment. The term is used differently by different people, Emerson told Aventine. It's not a scientifically precise term, and there's a bit of marketing mixed in with the science. For Emerson, quantum supremacy demonstrates the ability to maintain quantum coherence and entanglement on a large scale. When you conduct a quantum supremacy experiment, you're showing that you can maintain that quantum magic on a large enough scale to do something that's extremely challenging for a classical computer, he explained. Gil Kalai, Quantum Supremacy may be unattainable. Gil Kalai, a mathematician and computer scientist at Hebrew University, takes a more skeptical stance, theorizing that quantum supremacy might be unattainable due to the inherent noise and instability in current quantum systems. Quantum supremacy is significant both as a milestone and as a step towards something greater, Kalai told Aventine. However, he added, my theory is that quantum supremacy cannot be achieved, based on an analysis of the stochastic behavior of samples from quantum computers on an intermediate scale. Kalai argues that the combination of noise-sensitive and noise-stable elements in today's quantum computers makes achieving quantum supremacy unlikely. With this combination, quantum supremacy is out of reach, he concluded. Shivaji Sandhi. A physicist's take on quantum supremacy from a physicist's perspective. Shivaji Sandhi, a professor at Princeton University, sees quantum supremacy as a reflection of our growing ability to control quantum systems. For Sandhi, the concept is less about outperforming classical computers and more about the complexity of quantum behavior. I'm a physicist, and my approach to this is somewhat different, Sandhi told Aventine. What we aim to build are highly controllable quantum devices with an extremely high degree of control over their behavior over time. For quantum supremacy to be useful in physics, it would mean having a system so complex that we can't predict its behavior using traditional methods, forcing us to engage with the quantum system on its own terms, much like we do with experimental systems. Sandhi believes that this form of quantum supremacy, where the behavior of quantum systems defies classical prediction, is a goal worth striving for. That's the kind of quantum supremacy that resonates with me, and it's absolutely a goal worth pursuing, he said.